Today we are going to tell you about the thermodynamics process in energy conversion engine. First of all, we would like to tell you about ourselves. My name is Rahman and my friends.
I'm Dika.
I'm Vicky.
I'm Alif.
That's all our introduction. Let's check it out.
In this occasion, our group will explain you about energy conversion engine. Energy conversion engine is an engine that transforms energy from one state to another state. For the example is petrol engine. There are two kinds of petrol engine, two-stroke and four-stroke. And today we will take a four-stroke engine as an example. Do you know actually this engine called four-stroke engine is because it has four steps in every combustion. The first step is intake or suction, where the piston is at the lowest point or bottom dead center. At the same time, the mixture of fuel and air is flown into the combustion chamber.
This is the intake process, starting with first stroke, known as suction stroke. During this stroke, which is also known as induction stroke, the piston moves from top dead center to bottom dead center. The inlet valve opens and piston-propagated fuel-air mixture is sucked in the engine cylinder. This operation can be represented by a line on pressure-volume plane. The exhaust valve remains closed throughout the stroke.
The next step is compression process. In this process, the mixture of fuel and air is compressed by the piston that moves from the bottom dead center to the top dead center. It creates the highly compressed mixture that ready to fire up by the spark plug.
Moving on to the second stroke, which is known as compression stroke. In this stroke, the piston moves towards top dead center and it presses the enclosed fuel-air mixture down in the engine cylinder during suction. The pressure of the mixture rises in the cylinder to a value of about 8 bar. Just before the end of this stroke, the operating plug initiates a spark plug which ignites the mixture and combustion takes place inside the cylinder. This stroke can be represented on the pressure volume plane by line 2 till 3. Both the inlet valve and exhaust valve remains closed during the stroke.
The next step is combustion stroke, where the spark plug firing the mixture to make an explosion that forces the piston to move downward to the bottom dead center.
Now let's see the third stroke, known as working stroke, when the mixture is ignited by the spark plug. The gases are produced which drive or throw the piston from the top dead center to the bottom dead center, and thus the work is obtained in the stroke. It is during the stroke when we get work from the engine. The other strokes, namely suction, compression, and exhaust, being idle. The flywheel mounted on the top of the shaft stores energy during the stroke and supplies it during the idle strokes. The expansion strokes is shown on the pressure volume diagram 3 and 4, but the valves remain closed during the start of the stroke, but when the piston just reaches the top bottom dead center, the exhaust valve opens.
And also the last step is exhaust stroke. As we know, in the combustion chamber there are two valves, the intake valve and the exhaust valve. In these steps, the intake valve is closed and the exhaust valve is open. And the piston move upward, pushes burnt gas to the exhaust valve. And the piston move upward, pushes the burnt gas to the exhaust valve that opened before. These four processes happen continuously in the combustion chamber.
Moving on to the last stroke, known as exhaust stroke. This stroke is the last stroke of the cycle. Here, the gases that are being collected become useless after the completion of the inspection stroke and are then escaped through exhaust valve to the atmosphere. This removal of gas is accomplished during the stroke. The piston moves from bottom dead center to the top dead center and the exhaust gases are driven out of the engine cylinder. This is also called a scavenging. This operation is represented by line 1 until 5 on the pressure volume diagram.
And this is the PV diagram, the pressure versus volume diagrams, and we want to explain about the thermodynamics process that happens in the four-stroke engine combustion. The first slide, this is the intake process that happens in the isobaric that there is no change of the pressure when this process is happen. It's only the volume that expand. We can see from this to this, and it shows that the volume is increased.
The next line is the compression line. This line shows that this process happened in adiabatic condition where there is no heat flow into or out from the system. The volume of mixture decreases and the pressure of mixture is increased to the maximal pressure.
This is the adiabatic line. As we know, that adiabatic is there is no heat flow into the system or out from the system. And the last is in the exhaust process, it shows from this line. It happens it's divided into two conditions when it is isovolume and isobaric. Isovolume that there is no change of volume, and isobaric that there is no change of pressure. From this, the pressure is become lower and lower, and until the lowest pressure, the same as the initial pressure in the combustion chamber, the volume is decreased back to the initial condition, back to the initial pressure and the initial volume in the combustion chamber.
Okay, this is the end of our presentation about four-stroke engine and its thermodynamic process. Thank you so much for your attention and see you next time.